This is the Progress Check 3 homework video for intermediate algebra. The learning targets that were addressed on this progress check were to identify the key characteristics of quadratic graphs, meaning the x and y intercepts, line of symmetry, and vertex, from both standard form and factored form, and to sketch accurate labeled graphs of quadratic equations. There's some general patterns that, if you can keep these in mind, will always help you remember how to find all these pieces of information. With the x-intercepts, regardless of what form you're using, the main goal is always to set the equation equal to 0, then solve for x. With the y-intercept, we always want to plug 0 in for x, and then solve for y. With the line of symmetry, that can always be found by calculating the number halfway between the x-intercepts. And we can do that by adding the x-intercepts together and then dividing by 2. And then finally the vertex. The x value of it is the line of symmetry, and the y value is found by plugging the line of symmetry in for x, then solving for y. So if you notice how all the information is connected together, if you find the x-intercepts first, finding the x-intercepts will help you find the line of symmetry, and then finding the line of symmetry will help you find the vertex. So quite often I will go in that order when I'm finding that information. When you're working with standard form, there is a separate trick for finding the line of symmetry that can be faster than looking halfway between the x-intercepts, and that's to use the opposite of b over 2a. So that's a good shortcut that you can use, but if that's something that you forget, then just looking halfway between the x-intercepts will always help you identify the line of symmetry. So let's take a look at this first example, which is written in standard form. We've got 3x squared minus 20x minus 32. We'll find the x-intercepts first by setting the equation equal to 0, then solving for x. In previous problems that looked like this, where we have it in standard form and the rule is equal to 0, we solve this type of equation using quadratic formula. And so just as a reminder, here's the quadratic formula again. You don't have to memorize this, and it will be written at the top of progress checks and tests. First, we need to identify our a, b, and c values. In this case, a is 3, b is negative 20, and c is negative 32. Once we have those numbers identified, we can go to the quadratic formula and replace all the letters with the appropriate numbers. In the first fraction, the numerator says opposite of b. Our b value is negative 20, so the opposite of b is positive 20. In the denominator, it says 2 times a. So my a value was 3, so I'm going to write 2 times 3. Then I'll put the plus or minus. Now the denominators of these two fractions match, so I'll go ahead and write 2 times 3 in the denominator of the second fraction as well. Now the numerator of this fraction is the most complicated part, where the square root is. So I start by finding what's under the square root, and then take the actual square root as the second step. So first I'll keep the square root sign there, and then I'll plug in all the numbers for b, a, and c. So we've got negative 20 squared minus 4 times 3 times negative 32. And that's the part of the quadratic formula where the c value shows up. That's the only part. And all the other parts of it, we only use the a and the b value. So my next step will be to simplify some of the parts of those fractions. So instead of writing 20 over 2 times 3, I'm going to write 20 over 6. I'm going to have a 6 in the denominator in the other fraction as well. And then in the numerator of the second fraction, I'm going to go ahead and figure out what all that is underneath the square root. So I'll plug that into my calculator as I see it, negative 20 squared minus 4 times 3 times negative 32. And I'm going to make sure to put that negative 20 in parentheses with the squared on the outside, just like I have it written. And I end up with 784. Now I'll go ahead and take that square root, and I end up with 28. And now I'm ready to do the addition and the subtraction to get my two solutions. So for the addition, I'll have 20 plus 28, and then I'll divide that by 6. So 20 plus 28 is 48, and then we'll have 6 in the denominator. And then for the subtraction, I'll do 20 minus 28, which will give me negative 8, and that also will be divided by 6. So now as my final step, I'll divide each of those numbers by 6, and I end up with positive 8 and negative 1.3. So those two values are my x-intercepts, and again, we get two values because within this formula we have to both add the two fractions and subtract the two fractions. These are x-intercepts, so I'm going to write them as ordered pairs with the numbers coming first and then zeros in place of the y values. Next I'll find the y-intercept, and I can do that by plugging in 0 for x and then solving for y. So I'm going to rewrite the equation, but I'm going to replace all the x's with zeros. Then I'm going to start simplifying that. So 3 times 0 squared just ends up being 0, and negative 20 times 0 just ends up being 0. And so when I get rid of all the zeros that I have in there, I just end up with y equals negative 32. So the y-intercept is also a coordinate on our graph, and so I'm going to write that as an ordered pair with 0 in place of x and negative 32 in place of y. Next I'll find the line of symmetry, and as I've mentioned already, when you're using standard form, a shortcut for the line of symmetry is just to use the opposite of b over 2a. Since we already identified our a, b, and c values, this is a very simple way to identify the line of symmetry. The opposite of b is going to be positive 20, and then 2 times a is going to be 2 times 3. That simplifies to 20 over 6, and when I do that division, I end up with 3.33. Now the line of symmetry is not a point on the graph, it's a line, and so I'm not going to show it as an ordered pair. I'm going to show it as an equation that's set equal to x. Last, I'll find the vertex. By knowing the line of symmetry, I already know the x value of the vertex, because the vertex has to lie somewhere on the line of symmetry. So in order to find the y value of the vertex, I take the line of symmetry and plug it in for x. So I'm going to rewrite the equation, but replace all the x values with my line of symmetry. And then I'm just going to type that into my calculator as I see it. I end up with negative 65.33. So that's going to go in place of the y value of my vertex. Now I've got all the information that I need. Those are the 4 key characteristics, and so I'm ready to sketch a graph. I'll plot the x-intercepts first. If you want to put tick marks on your graph, then that's fine, or sometimes you're given a scale to work with. But otherwise, as long as you label all your information, then we can tell what type of scale that you're using, or that you know what side, whether it be positive or negative, that all your information is supposed to go on. So I'm going to graph my x-intercepts first. Then I'll graph my y-intercept. Next will be the line of symmetry, which should be placed halfway between the x-intercepts. And then the vertex, which I need to make sure to place lower than the y-intercept, since the y value of the vertex is a much bigger, lower number than the y-intercept was. Once I have those 4 pieces of information graphed, then I can go ahead and sketch my parabola. Now we'll look at example 2, which is a quadratic equation written in factored form. Again, we'll start by finding the x-intercepts, and we do that by setting the equation and solving for x. When we have factored form and it's set equal to 0, the most efficient way to solve that type of equation is to set each factor equal to 0 and solve for x. So with the first factor, I end up with an x value of negative 1. With the second factor, I end up with an x value of 6. So I'm going to write both of those as ordered pairs, replacing the x values with negative 1 and 6, and then the y values was 0. Next I'll find the y-intercept by plugging in 0 for x. So I'll rewrite the equation, replacing all the x's with zeros. And go ahead and do that multiplication to end up with positive 6 for a y-intercept. Again, I'm going to write that as an ordered pair, with 0 in place of the x and 6 in place of the y. Since I already found my x-intercepts, I can go ahead and find my line of symmetry by identifying the number that's halfway in between the x-intercepts. So I'm going to add those two x-intercepts together, which gives me the value of 5. And since I need the distance that's halfway, I'm going to take 5 and divide it by 2. That gives me an x value of 2.5 for my line of symmetry. Finally, I can find my vertex. Since I know my line of symmetry, I already know the x value of the vertex. I just need to plug in my line of symmetry in order to find the y value. So I'm going to rewrite the equation and replace the x's with the value for the line of symmetry. I'll go ahead and multiply those numbers together, and that gives me 12.25. So now I have my 4 key characteristics, and I'm ready to sketch a graph. I'm going to label my x-intercepts first, then my y-intercept, my line of symmetry, which needs to be halfway between the x-intercepts, and then my vertex, which this time needs to be higher than my y-intercept, because the y value of my vertex is higher than the y value of my y-intercept. If I tried to connect this information with a parabola that opened up, I wouldn't be able to get it to fit. So if we take a look at the rule, notice that there's a negative in front of the rule. That means that this parabola opens down. And so if we connect the information that we've got on there with a parabola that opens down, it's a much better fit. Okay, now go ahead and try the 2 practice problems that are on your homework. I hope this video helps clarify some things, helps remind you how to express all this information, what's supposed to be ordered pairs, what's supposed to be written as equations. And if you have any follow-up questions, be sure to ask.